Question 7.2. We are given an equation showing how solid barium hydroxide dissolves in water into its ions. We are told the volume of water is 100 centimeters cubed and the temperature is 25 degrees Celsius. The amount of barium hydroxide dissolved in the water is unknown, so we don't know the moles of barium hydroxide dissolved. Since the barium hydroxide dissolves into barium 2+ ions and hydroxide ions, this is what the solution looks like after dissolution. There is 1 barium ion for every 2 hydroxide ions. We're then told that 25 centimeters cubed of the barium hydroxide solution is mixed with 15 centimeters cubed of hydrochloric acid. And we're given the concentration of the acid, it is 0.2 moles per decimeter cubed. We are told that this is the reaction equation for the base and acid reacting, and we know this is a neutralization reaction and that a salt and water are produced. When these two solutions have reacted, the pH of the resulting solution is 12.62. Since the pH is basic, we can deduce that there are some unreacted hydroxide ions from the base in the solution. The first question asks us to calculate the concentration of hydroxide ions in the final solution. We know that pH plus pOH is equal to 14. We can rearrange the equation for pOH and substitute the pH value of 12.62. This gives a pOH of 1.38. We can now use the pOH to get the concentration of hydroxide ions. Using this equation, pOH is equal to the negative log of the concentration of hydroxide ions, which, when rearranged to get the concentration of hydroxide ions, is equal to 10 to the negative pOH. Substituting the pOH value of 1.38 for the exponent and solving, we get the concentration of hydroxide ions in the final solution of 0.0417 moles per decimeter cubed. Next, we need to find the number of moles of barium hydroxide used to prepare the original solution. From the concentration of the acid and its volume, we can deduce that 0.0030 moles of acid reacted. And we know that 1 mole of hydrogen ions from the acid neutralize 1 mole of hydroxide ions from the base. So if 0.0030 moles of hydrogen ions from the acid reacted, then the same number of moles of hydroxide ions from the base reacted. But after these reacted, there were still hydroxide ions in the flask. So the moles of excess hydroxide ions is its final concentration times the volume it is in. And the final volume is the sum of the volume of the acid and base, which reacted together. Solving, we get the excess moles of hydroxide ions, which is 0.00167 moles. Now we can find the total moles of hydroxide ions originally present in the 25 centimeter cubed sample by taking the sum of the moles reacted and the moles left over. And we get 0.00467 moles of hydroxide ions in the 25 centimeter cubed sample. Then, since 1 mole of barium hydroxide produces double the moles of hydroxide ions, we can halve the mole value to get the moles of barium hydroxide in the 25 centimeter cubed sample. And this value is 0.00233 moles of barium hydroxide in the 25 centimeter cubed sample. All that is left to do is to multiply this value by 4 to get the moles of barium hydroxide in the original 100 centimeter cubed solution. Doing this, we get 0.00934 moles of barium hydroxide dissolved initially in the 100 centimeters cubed of water.